Alright guys, so in this video I'll be going through FreqAI introduction and configuration, like how it works basically and what are the guidelines to you know build a machine learning system and deploy it and trade it live as well. So introduction. FreqAI is a software designed to automate a variety of tasks associated with training a predictive machine learning model to generate market forecasts given a set of input features. Features include self-adaptive retraining. So this feature is different from this feature. Okay, this is input feature. Features in machine learning world, whatever we can measure about the market, basically that would be our features. So for instance, let's say okay, let's see. Okay. Anyway, so in market, what data we have in the market? Well, in the market we have open. All right, open. Let me. Okay. Well, in the market, what data we have is open, high, low, close. Okay, that data we all have. Open. Well, we have date as well. Let me just go to the blackboard basically and show you what I mean. Okay, so we have open, high, low, and close, and also we have also a date. So this is our data. Okay, and this can be our feature as well. Features. All right, now what we got to do is first what we have is all this data and volume as well. Okay, volume is the very most important thing. All right, now we can deduce more information from these 4 column, 5 column, okay, or 5 or 6 column including date, and we can generate many features. All right, we can generate like millions of features. Okay, memory is the limit here. Okay, but even memory is not the limit, just the imputation of the data. So for instance, we can like get the close percentage change. So as we will be working on pandas data frame, we have like df close, and then you just do percentage change, and it will return the 1 minus previous close by close shift 1. So it will be like 1 minus close 1 by close 2. Okay, this will be our percentage change. Okay, and we can also like deduce the high, or also suppose we want to like get the maximum of high of last 10 bars. Okay, so we will get this data, all this data from TradingView, so don't worry about that. And like we can like generate more than 10k plus features based on users and created strategies. Like we can like do rapid feature engineering. Okay, so well, let's see what's the feature FreqTrade provides us. The first one is self-adaptive retraining. So it actually retrains our models during live deployments to self-adapt to the market in a supervised manner. All right, let me do the theme. Okay, now, okay, the right theme is good. Okay, now we can do rapid feature engineering, which means that we can create large rich feature sets with 10k features based on simple user created strategies. All right, now like just which I just explained here. Okay, here, and now if I like okay, now what other features we have is high performance. Okay, which is very like essential to the machine learning and deep learning, especially deep learning and reinforcement learning model. Right, you need high-end GPU to train the model. All right, Now, for it actually it provides that threading allows for adaptive model retraining on a separate thread or a GPU if available. All right. Now, from model inferencing, prediction, and bot trade operations, newest models and data are kept in RAM for rapid inferencing. So, like inferencing will be like in a millisecond. Okay. Now, realistic backtesting, it provides realistic backtesting, which says that like it emulates self-adaptive training on historic data with a backtesting module that automates retraining. Okay, so it basically incrementally, like it basically does this cycle of training and then back propagation or retraining all right. Now this back propagation is different from like it is mainly used for deep learning. I'm actually going ahead myself. I'm actually assuming like you guys should know like little bit of deep learning, machine learning, artificial like reinforcement learning, all these area of artificial intelligence, all right. And then what you also gotta know is something little bit or have a basic idea of technical analysis, all right, so that like you basically understand like basic function of the market, okay, how the market works, all right. Now that's a part. Let's go on. And so we have like deep learning, we have machine learning, all right. Now we have reinforcement learning, all right. I actually went like so. This will be our first step. This will be second, and this will be third. Or we can like we can use them like most best model which I saw or build is like the combination of all this. Okay, because you need machine learning for some other feature, you need deep learning for certain different tasks, and you need reinforcement learning for like putting all these things together. Okay, now uh, okay, so realistic backtesting we were talking, so it basically like it is self-adaptive learning, meaning it will like first train and then go back and retrain, because in market we need like that awareness. Basically like we have funny definition of awareness, but let's for a moment suppose that our ML model is aware, all right, of its environment, which is this market, and it will like first learn something about it and then retrain itself, and then this cycle goes on like infinitely, and also like how many time you define. So like if you want to like train um, train on each hour or each week or each day, it depends totally depending on how much like which type of trading you want to do. Do you want to do like day trading, intraday trading, or and I think basically machine learning models are particularly useful for I think in day trading, which is intraday trading, all right. So we will be using lower time frame, 5 minutes, 15 minutes, 1 hour for like larger perspective. Okay, now so with that apart, let's go ahead and see extensibility, all right. So the generalized and robust architecture allows for incorporating any machine learning library method available in Python. Okay, so we can extend it to any machine learning library. So we can use like TensorFlow. Okay, we can use PyTorch. All right, like for TensorFlow, we can go ahead and like see. We can go and go with Keras, like building like vision transformer using like transformer architecture, all right. Architecture from our Hugging Face. It basically, so like we can extend it to any library. What why I'm telling you is this, because most like this is the first library I've seen in like in lifetime basically, if you see it in open source space. And so uh, We can use TensorFlow, PyTorch, sklearn. What else we have? Like CatBoost. We have XGBoost. Right? We have AdaBoost. We have LightGB DM model, GDM model. So we have this all this deep learning library from Google, Facebook, Microsoft, and independent library as well. Okay, so we can use like extend it to and even create our own custom Python scripts or Python like library, and we can extend it to however we want. Okay, now 8 examples are currently available, including classifiers, regressors, and a convolutional neural network. Okay, so classifiers and regressors are the part of machine learning, and deep neural networks. This convolutional neural networks is part of our deep learning. Okay, so now let's move on. We have a smart outlier removal. We have like remove outliers from training and prediction data sets using a variety of outlier detection techniques. Okay, so there are many outlier detection techniques, like we can use SVM. We can use, yeah, like SVM. We have SVM. We have DB scan. All right, we have all these like this smart system which basically says that if your data is valid or not, if your data is valid or not, because we don't want to feed crap into our machine learning model. All right, because these systems are like very sensitive to data we give. Okay, so if you give suppose like a crap uh, data, I actually shouldn't say crap, but like most of the time when you like go ahead and train the model, and like even a small change changes the model's performance, or like changes its behaviors on prediction, it really like I mean, it really drives you nuts. So, so keep that in mind that this is really, really important. All right. So, SVM and DB scan, we can use all these amazing algorithms to remove our outliers. Okay. Now we have crash resilience, which ensures that it stores trained models to disk to make reloading from a crash fast and easy, and purge obsolete files for sustained dry library. So what it does is basically it saves the model on our disk so that we can like use it for later back testing, and don't actually start training from the start. We want to like learn from the experience. All right, learn from the experience. Okay, so the experience will go up, all right, with our like training model. All right, so this will be our cycle, and so we want that feature here as well. Okay, and we have here. Now let's move on and see. We have automatic data normalization. This is quite important. All right, so normalize the data in a smart and statistically safe way, meaning like we have to normalize the data saying by x minus mean by it will be like, I think it's uh, yeah, x or something like this, and you can say like standard deviation or something. I don't know what they use. Okay, so uh, I I I actually might be wrong here. Let's see. So it's basically like when you know how you wanna normalize the data. So suppose you have like 1,000, okay, 10,000 data. You wanna basically normalize the data to 0 to 1. All right. So what you can say, like if you have 990,000 here, so you will take the maximum of it, and divide it each of them, and then you will get the value. So it will get 1, it will get point something. Okay, so wait, right, so we don't want to give a large value there. Okay, we want to like normalize our value, and that features we have here. Okay, which is very, very important in a statistical manner. Okay, now we have our automatic data download, which compute time ranges for data downloads and update historic data in live deployments. Okay, So it actually automatically downloads data uh, on update the data in live deployments. Okay, now we have cleaning of incoming data, which handles NANs safely before training and model inferencing. Okay, so this is also a good feature. Now we have dimensionality reduction, which actually reduces the size of the training data via PCA, principal component analysis. All right, so we have that, and now we have one feature as well, that is deploying bot rigs, which set one bot to train models while a fleet of follower bots inference the models and handle trades. So this is really the like craziest and amazing features of it. Okay, this is like uh, what we call it in mobile training is like uh, informative learning or something. So yeah, it basically how it does is like, suppose like how Google does is they have a central system. Okay, central system, right? Central system, and we have all this mobile, right? How they use their model is that this is their main model, and like all these machines inference from this model, it trains, gets the data back, right? Data back, and like it like inferencing, updating the model here. So it like it syncs all this, it like it basically solves the holy grail of, I mean not holy grail basically, but holy grail of technical problem in training the deep learning model, like at this point for for now. Okay, uh, so now what we have is, now let's get started. So how do we start with FreqAI? Is the easiest way to quickly test FreqAI is to run it in dry mode with the following command. So we do freq trade, we pass it config file, and we pass the strategy, our FreqAI example strategy, and we pass which model or regressor or machine learning or deep learning model we wanna use, and use to train the ML system, and we pass the path of the strategy. Okay, so it will like run in dry run mode and basically execute a live trade as well. Okay, now you will see the boot up process of automatic data downloading followed by simultaneous training and trading. Okay, I have actually done it, and yeah, it works great. Okay, and now um, okay, you know what, let me just show you. Okay, because it will be easier to like have a picture of it. um, Let me just show you. Okay, real quick. um, so here we have this system over here. Okay, so um, 34.168.146.243 and then 8071. Okay, this is our FreqAI example. Okay, this is our AI trading system. Okay, let's call it. Okay, the AI trading system. Now uh, pass it password here, and let's see. Okay, so see here, it's running, and let me show you the log. Okay, let me show you the log here. See, it actually gets the data. Okay, and train it. Okay, see, for alpha USDT it took 25.23 seconds here. Now I started training for Alice, trained. So this is a good message here. Dropped 0 training points due to NANs in populated data set, and then training data starts from 10.8 to 10.23. So around 27, around 20 days or something. Okay, and so this is how it goes. Okay, and see this all these logs here, right? So here see it found order for pair KCTK USDT, and we are entering with this amount. This short is false, so we are entering long. Leverage is 1, open rate is this much, and open since this time. Okay, so this is how it is doing, and you can see the performance here. All right, you can see the performance that like we see this steadily rising curve. All right, and let's see the trade as well, if we can see. Right, see exit signal and all these trades over here, right? And now let me show you, um, let me show you the chart here. Okay, see it entered long here, I mean long signal executed here, it entered long here. Okay, actually exit, yeah, long here it was entered long entry. Okay, so yeah, we can go ahead and look at any chart. Okay, we can also go ahead and look the Heikin-Ashi candlestick. So yeah, it's actually pretty cool. All right, so now let's go to the our uh, this one. Okay, so we have done this. All right, now after this what we can see is we have seen the boot up process, training, testing, and also like deployed on live. Okay, so an example strategy, prediction model, and a config to use as a starting points can be found in this FreqAI example strategy. Model is this, and our config example is this. So let's go ahead and see that. Okay, so we have config examples. So this is our config, FreqAI config, this one. Okay, so we have all this fixed rate config, which was a standard fixed rate model, and then now we have our config for FreqAI model, is this which will be like reading about later. Okay, now what else it's saying in the example is we can get the um, strategy as well. So strategy is not there, so we want to like get the template strategy. So we go to FreqAI templates, and here's our FreqAI example strategy. So see, we inherited the AI strategy interface. Okay, and then so this is populate and indicators. Here we populate all the indicators which will be reading later, and this is like usual fixed rate stuff. Okay, so yeah, all right. Now so we have our templates, and now we can get our model as well. So go to FreqAI and see the prediction models, and we can get our prediction models as here it was shown LGBM. Okay, GBM regressor, so it is here. uh, this is our, we can inherit this base regressor model. It is fitting, just we get the data and just we are fitting the model on regressor, and yeah, it basically does all, like most of the things automatically, right? We just have to pass the data, and we can get all these different models. We have TensorFlow model, cat boost classifier, cat boost regressor, cat boost regressor multi-target, light GBM classifier, regressor, and regressor multi-target. So this is all useful. I mean, most interesting thing is this one. Okay, in the future I'll be like making videos on like how to build this TensorFlow model, because I don't see any example over here. So yeah, we'll be doing that. So we can inherit a train. Okay, uh, we just have to train, and yeah, that's it, right? So that's our prediction model. Now let's go to our introduction. Okay, now general approach. You can provide FreqAI with a set of custom-based indicators, the same way as in typical Freq trade strategy. Okay, as well as target values labels for each pair in the whitelist. FreqAI trains a model to predict the target values based on the input of custom indicators. Okay, the models are then consistently retrained with a predetermined frequency to adapt to market conditions. Okay, FreqAI offers the ability to both backtest strategies emulating reality with periodic retraining on historic data and also deploy dry or live runs. In dry or live conditions, FreqAI can be set to constant retraining in a background thread to keep models as up to date as possible. So here, see in the log, if you go in the log and see here, it is like constantly training every hour or so, and also like see SVM, this classifier, this outlier is tossing out all those outliers from our training point so that our prediction doesn't get uh, affected. Okay, and that's how this performance is coming up. All right, see if you go to the stats here, our daily stats, see on the first day it made $43, which is 1.44% profit. Okay, now on the second day it made 0.85% profit, and on the third day it made 0.69% profit. So it is like a curve is rising curve, so it's working quite fine. All right, see rising curve, we haven't seen any drop down, like any catastrophic drop down or drawdown till now. Okay, so let's go and see. So we have this, and okay, so FreqAI can be set to constantly training up in a background thread to keep models as up to date as possible. All right, now an overview of the algorithm explaining the data processing pipeline and the model uses is shown below. Okay, important machine learning vector, and you know what, let me just go ahead and explain it to you basically what it is, and because it's very important. And also, as this is all like this is all integrated into FreqTrade, and like they have built a, let me just give them a credit and say that they have like abstracted a very huge problem for day trader or any research analyst, research scientist, anyone. Okay, so it's very important to at least appreciate like how what's going on in the background. All right, so let me just grab a pen and let's see. Okay, so first how we do is we create our strategy. What we do is we pass our data, which is candlestick data. This is our base features. All right, we expanded features, so we can like expand these features as with multiple time frames. We can add multiple time frames, we can add multiple indicator periods, so we can use like 5 SMA, 20 SMA, 30 SMA, 50 SMA, 100 SMA. We can use RSI, stochastic RSI, we can use average true range, right? We can use true range. All right, so like on my top of the head, like the most important, like suppose as like ATR is like measure of volatility. All right, it measures volatility. I mean, it is one of the best technical analysis out there for measuring volatility. Okay, RSI does the same for like observing overbought and oversold conditions. So that is very important information in order to like figure out tops and bottoms of the market, because we want to give market as much data as possible and as much good data as possible, so that it can like get apply some linear algebra to it basically and come up with its own thinking of what it means when we combine this and this and this, and what it means when we are in oversold condition. Okay, what it means when we are in overbought condition, what does it mean if the ATR is increasing. As a human, we know that when we see rising ATR, we see that like more volume coming in, more and more volume coming in. But if we pass the AI model just the open, high, low, and close and volume data, it can however do it, right? But you need a lot more data to train it, and that's why we do feature engineering to basically, it's basically a clever way to train the model. So yeah, and let me just list down a couple of technical analysis which are in my top of my head. So we have our cumulative wave volume. Now we have our percentage change in close. We have our we can see this sorting of the upthrust, sorting of the downward thrust, so that like we can like add those cumulative changes of close, right? We can add, we can do cumulative sum, and it will represent either like sorting of the thrust, or sorting of the upward thrust, or sorting of the downward thrust. All right. So I'm actually getting more technical here, but let me just stop right here and continue with the deep learning model. Okay. Now we have these pass candle features. All right. So this pass candle features is basically we can so as we have current day data, we can pass it last 3 days of data as well to train it and see like infer what it's going on and make a good decision here, okay, for the current day. Now after this, we apply feature set engineering and we get a cleaned, this is our feature set engineering, and now we get a clean features, all right, which basically removes any not a not a number values or none value, truncate those features, okay. And it also does outlier detection and removal, which is like we were using SVM for that one in the log I showed, right? Now normalization, okay, statistical analysis, and basically normalization, we use it for statistical stability. All right. Now we have dimensionality reduction with PCA. So if we have 10k plus features, okay, and we want to get the same result as this one, then we can use apply and like reduce this to like 5,000 features, 5,000 features, okay. From 10k to, we can reduce it to 5k, or we can reduce it to 1k. It depends on the like how much data, how much the basically data represent, okay, the current situation in the market, current market condition, as well as we can like we will actually get a feature importance plot, which will show that which features are most important, okay, and we can select it from there as well. Okay, actually, and see, in this process visual inspection is also very important, all right. So we will be doing that later as well. So now we move on to adaptive learning, and how it works is that we have running it on separate thread, and it basically does this, see that cycle which I showed earlier, right? It basically pass, okay. So first basically it will pass see, it will pass those data to here. We will get our target, okay. This will be features, this will be label, and then we will get to our this model and metadata storage. We can store it here, and from here we can also like take the saved model and like build, if first training, if it is first training, then we will do the whole process, or if it is like repeat or training again, then we will fetch the previous trained model and we will update each retraining, okay. So we will go on this cycle, okay. Now after that we will store that, we will continuously store that to our local disk, and also we will update to the RAM as well for faster inference. Now after that we can like purge the old models, okay, and then our predictions are, we can get our predictions from here, all right. So so see, one of the benefit of showing this step is to, so that like how we can save some time on each of these steps. So like suppose if you don't want to purge the old models, just set it to true, all right. If you want to like train it for 1 hour 2 hours, that's also a, like we can optimize it. Basically we are doing some like process hyperparameter optimization, if you will. All right, now we can get the predictions. This is our model inferencing, and then we can do the post processing where we can, which usually means like denormalization. So we will get the actual value which we pass to the model. All right, now we will gather statistical quantities, okay, as well, statistical properties, and then we determine the prediction confidence from like we can use this DI dissimilarity index, like if our prediction is far away from our like index which we define, so we can like see if we are if the machine learning system is confident in its prediction or not. Okay, and then we pass those action codes to here to enter our to handle our those like prediction, to handle our entry exit and logic with predictions. Okay, and yeah, so that completes the whole cycle. And this prediction, like see this here, see here, it is this entry exit logic is very like abstract here, but basically you can do like enter at specific point, like entry, suppose entry, right, stop loss, you can get trailing stop loss. Okay, suppose if you like set the trailing stop loss to ATR value, right, to ATR, all right, you trail it and you give this model, and the machine learning model will predict the next value where to put our trailing stop loss, which will be far better than ATR. This is really amazing, man. All right, so we can get our trailing stop loss, then we can uh, basically do an early exit as well. We can set some parameters, so we can do all sorts of, we can get like all sorts of our predictions. So yeah, all right, it's just like entry and exit logic, we can like define it there. Okay, and then that's the prediction and that's our like training data. Okay, and this is how we are doing the training. Okay, now let's move on. So okay, so we have completed that, and let's go with this machine learning simple vocabulary, so like refreshing. Okay, so we have features, the parameters based on historic data on which a model is trained. All features for a single candle is stored as a vector in FreqAI. You build a feature data sets from anything you can construct in the strategy. All right, now the labels, the target values that a model is trained toward. Each feature vector is associated with a single label that is defined by you within the strategy. These labels intentionally look into the future and are not available to the model during dry, live, and back testing. Okay, so it is just a target to train the model. Okay, now we have training, the process of teaching the model to match the feature sets to the associated labels. Different types of models learn in different ways. More information about the different models can be found here. So like training will be, so suppose here labels will be, we can put our stop loss, and as in previous example ATR value here. Okay, so we can get, how do we set a stop loss, trailing stop loss. Okay, ATR value. Okay, which will be like either is it 2 times, is it 3 times, so we can like get our prediction over here. And that's our labels. And training is just the like well, this is the term, right? So we are, training is how we teach the model. Okay, how we teach the system. Now train data, a data set of the feature data set that is fed to the model during training. This data directly influences weight connections in the model. Okay. So that's our deep learning, that weight uh, in the that multiplication in our directed graph of linear algebra. All right. Now we have test data, a subset of the feature data set that is used to evaluate the performance of the model after training. this data does not influence nodal weights within the model. Okay, so it is just a test data. Basically, we don't touch it, we don't do anything with it. We just, we test it on the learned system to test if it has learned the system or learned the data, training data, good or not. And that's how it, like, you know gets its weights from. So basically, uh, it's loss, not, we don't show it the actual data, but it's just the, uh, you know the loss of, like, how well the system is learning. Okay, now inferencing is the process of feeding a trained model new data on which it will make prediction. Okay, so after training the data and we want to get the next prediction, what's going to happen in the market, whether should we enter long, short, that's what we call inferencing. Okay, now this is our install prerequisites which I have done already. Okay, and here's our note. So cat boost will not be installed on ARM devices, which is Raspberry Pi, Mac M1, ARM based VPS. Okay, since it does not provide wheels for this platform. Okay, so cat boost, our classifier, is only can be installed on Linux based system like uh, AMD, or yeah, AMD system, Intel, that's that all. Okay, now we have users with Docker. So if you want to, like, if you are using Docker, a dedicated tag with FreqAI dependencies is available as FreqAI. As such, you can replace the image line in your Docker compose file with image. This image contains the regular FreqAI dependencies similar to native installs. Cat boost will not be available on ARM based devices. Okay, so that's how I deployed this system. Actually, I had used the Docker file for deploying that one. Okay. Now, common pitfalls of FreqTrade is that FreqAI is that it cannot be combined with dynamic volume pair lists, which is fine, I think, or any pair list filter that adds and removes pairs dynamically, because we got a, like, make a list of these pairs and have it in memory as well. So we want kind of like static pair list. Okay, now this is for performance reasons, and FreqAI relies on making quick predictions and retrains. To do this effectively, it needs to download all the training data at the beginning of a dry live instance. FreqAI does stores data and appends new candles automatically for future retrains. This means that if new pairs arrive later in the dry run due to a volume pair list, it will not have the data ready. However, FreqAI does work with the shuffle pair list or a volume pair list, which keeps the total pair list constant but reorders the pairs according to the volume. Okay, yeah, that this is very important feature. So how, if like, we should ask a question like what moves the market, and market moves basically with volume. Okay, and as we have, like, if we have 50 coin pairs, right, on some days 25 of them will have more volume than other 25. All right, in other days 10 of them will be like, have more volume than 40 of them. So we'll be focusing on like which have more volume. All right, so that we can, like, so that, like, we can capture more big moves here than stay on a trade on the low volume pairs basically. So that's also a good feature, but we gotta keep our volume pair list contest constant, and we can also use shuffle pair list, so that we can shuffle the coin pair randomly. All right, and take the, like, which one, because random distribution basically, like, it shifts it like on the long term it will go to that mean, and that's how we get that system is performing or not. And right, so yeah. which is very important because you don't know, like I mean, we can't anticipate or predict what's going to happen in the market next, but machine learning system might be able to do it, and that's why I'm doing it. That's why I'm recording this video and like documenting it live to see that like how we can use this system to our, like how we can join the force with AI to like uh, work with in contribution or in conjunction with AI. Okay, so all right, so I'm getting a bit philosophical there. So it's just like, right, I think it will be able to I think what I'm most interested to learn from this is that I want to learn from the AI system. Okay, and right now we don't have that much AI system, but we have machine learning, we have deep learning, we have reinforcement learning, and this is where my, like, I want to focus on mostly, I think. But the process of developing the reinforcement learning system is incremental, going from ML to DL, then DL to RL. Okay, so and then yeah, and then we can use this follow mode for like uh, to train build a one system. Okay, uh, so we can get the inference from that one system. All right, so all right, so I think that's it for this video. And so these are, I think we must give credit to these guys. uh, they have developed amazing software here. So in the next video, I'll be going through configuration file and showing you basically what we can configure, how we can configure, and what we should and we should not do, and also like what's the how do we basically go ahead and start building the FreqAI, the immortal AI trading system. So I'll see you guys in the next video. Thank you.